A rational function, first of all, is any function that can take on the form f of x equals p of x over q of x, where p and q are just polynomial equations. So rational functions are normally in fraction form. You can have any kind of polynomial in the numerator, any kind of polynomial in the denominator. The most basic rational function, or the parent function, is this function over here, f of x equals 1 over x. That's the most basic type. And you can see that that parent function has one vertical asymptote at x equals 0, or the y-axis, and one horizontal asymptote, or the x-axis, which is the x-axis at y equals 0. So we're going to talk about how to find the asymptotes for any rational function. We're going to talk about how to find the x and y intercepts, domain, range, and of course how to graph them. So let's start with horizontal asymptotes because it's pretty easy once you get the hang of it. To figure out where the horizontal asymptote of a rational function is, you're going to be looking at the degree in the numerator and the degree in the denominator. When I say degree, I'm talking about the exponent in the numerator and the exponent in the denominator. So for this one, we have a cubic function in the numerator, a quadratic function in the denominator. Because the cubic function is bigger and it's in the numerator, when the bigger degree is in the numerator, that means there is no horizontal asymptote. Bigger degree in the numerator, no horizontal asymptote. If the degree in the numerator matches the degree in the denominator, in this case we have a quadratic function in both the numerator and the denominator, then to find the horizontal asymptote, you look at the leading coefficients of those degrees. So our leading coefficient, we have a 3 and a 1. And so we take that ratio, 3 over 1, which is 3. So our horizontal asymptote for this function is y equals 3, the horizontal line, y equals 3. And then in the last example is an example where the degree is bigger in the denominator. The numerator is linear. The denominator is a quadratic. The higher degree is in the denominator. When that happens, the horizontal asymptote is always at y equals 0, or the x-axis, like that parent function that we saw on the first slide. So let's talk about how to find each piece. We'll do one at a time, starting with x-intercepts. X-intercepts always happen when the y is 0. You're looking for the x value that makes the y value 0. So to find the x-intercepts, you're going to plug in a 0 for the y. And when I plug in a 0 for the y, because these are rational functions, you can always start by multiplying both sides by the denominator. So if I multiply both sides by negative 4x plus 8, negative 4x plus 8 times 0 is just going to be 0. So really you don't have to mess with the denominator at all. To find the x-intercepts, you really only have to set the numerator equal to 0. And in this case, our numerator is a quadratic. So to solve that, I'm going to solve it by factoring. The GCF there is x. I'm left with an x plus 2. And then if I set each one of those equal to 0, I get x equals 0 and x equals negative 2. So this particular function has two x-intercepts. One x-intercept is at 0, 0, and the other x-intercept is at negative 2, 0. To find the y-intercepts happen where x is 0. So to find the y-intercepts, we're going to plug in 0 for x. So in this function, I have 0 squared plus 2 times 0 in the numerator. And in the denominator, I have negative 4 times 0 plus 8. So I get 0 divided by 8, which is 0. So this function has a y-intercept at 0, 0. My y value is 0 when the x is 0. And I could have known that by looking over here If my x-intercept is at 0, 0, that's also a y-intercept because that's the origin. All right, now the one thing we haven't talked about yet is how to find vertical asymptotes. To find the vertical asymptotes, you ask yourself, what can x not be? And we know for rational functions that the denominator can never equal 0. So the vertical asymptotes happen when the denominator is equal to 0. That's the number that x cannot be, and so it creates an asymptote there. So if I set the denominator equal to 0, I can find my vertical asymptotes. In this case, it's pretty simple to solve. My vertical asymptote is the vertical line x equals 2. And the horizontal asymptotes we already talked about. You look at the degree in the numerator and the degree in the denominator. So in this case, the degree in the numerator is 2. The degree in the denominator is 1. The higher degree is in the numerator. And when the higher degree is in the numerator, there is no horizontal asymptote. Let's try that again with another example. So if you remember, for x-intercepts, we set the whole function equal to 0. X-intercepts happen when y is 0, so plug in 0 for y. But really what that boils down to is just setting the numerator equal to 0, and that will give you your x-intercepts. If the numerator is 0, the whole thing is 0. So we have a quadratic to solve. I'm going to factor out an x, and I get 2 x-intercepts. X equals 0 and x equals 3. So I have x-intercepts at 0, 0 and 3, 0. Y-intercepts happen when the x is 0. So now I'm going to plug in 0 for x. So I have f of x equals 0 squared minus 3 times 0 over 2 times 0 squared plus 2 times 0 minus 12. Or in other words, 0 over negative 12. And 0 divided by anything is 0. So once again, I have a y-intercept at 0. And once again, I could have known that because one of my x-intercepts was at 0, 0, and that's the origin. So that must be my y-intercept also. Vertical asymptotes are the x values that we can't have, the x values that make the denominator 0. So we're going to set the denominator equal to 0 here and solve. The denominator is a quadratic. And so to solve this quadratic, I'm going to first divide everything by 2 because there's a GCF. And then I'm going to solve this by factoring because it is factorable. And so I end up with 2 vertical asymptotes, one at x equals negative 3 and one at x equals 2. Those are 2 vertical lines that if you were to go to graph this, the graph or the function that you're graphing would not cross those vertical lines. And then lastly, the horizontal asymptotes, we look at the degree. In this case, we have the same degree. When it's the same degree in the numerator and denominator, you look at the leading coefficients. We have a 1 over 2. So our horizontal asymptote is the horizontal line, y equals 1/2. Let's do some graphs next. So I always start by finding my asymptotes. I think that's helpful. So vertical asymptotes is what can x not be, what x value would make the denominator 0. So if I set this denominator equal to 0, I get a vertical asymptote at x equals 3. So on my graph, I'm going to go ahead and draw that in. And I know that my graph is not going to cross this line because x can never equal 3. And then to find my horizontal asymptote, I'm going to look at the degrees in the numerator and denominator. I have linear in the numerator, linear in the denominator. When the degrees match, you look at the leading coefficients. In this case, 2 over 1. So my horizontal asymptote is 2 over 1, or y equals 2. Now to graph this the rest of the way, I'm going to make an XY chart. And my XY chart I'm going to divide into two sections. I'm going to graph the left part of my graph, which would be left of my vertical asymptote. So my vertical asymptote is at x equals 3. So I want to plot some points to the left of x equals 3, and I want to plot some points to the right of x equals 3. So to not overcomplicate this, I'm just going to plug in 3 points that are right to the left of 3 and 3 points that are right to the right of 3. And when I plug in these points, when I plug in 2, I get 5 in the numerator and -1 in the denominator. So 2, -5 is my first point. When I plug in 1, I get 3 in the numerator and -2 in the denominator, so -1.5. And if I plug in 0, I get 1 over -3. So 0, -1/3. And then I'm going to draw this branch of the hyperbola, getting closer and closer to the two asymptotes. But now I need to know what's happening to the right of x equals 3. If I plug in a 4, I get 2 times 4 plus 1, that's 9, over 4 minus 3, that's 1, so 4, 9. When I plug in 5, I get 10 plus 1 is 11 over 5 minus 3, which is 2. And when I plug in 6, I get 12 plus 1 is 13 over 6 minus 3, which is 3. So a little over 4. And again, I'm going to draw that branch getting closer and closer to my asymptotes. And that's my hyperbola for this first graph. So here's another one. This one is not linear in both the numerator and the denominator, but just like before, I'm going to start by finding the vertical asymptote and the horizontal asymptote. So first, vertical happens. It's whatever value for x makes the denominator 0. In this case, that's x equals -4. So I'm going to draw in that vertical asymptote. There's only one again this time. And then my horizontal asymptote, we look at the degree. We have a degree of 2 in the numerator, a degree of 1 in the denominator. So there is no horizontal asymptote in this case. Then I'm ready to make my XY chart. I'm going to divide my graph into two sections because my vertical asymptote is at -4. I'm going to pick a couple points to the left of -4 and a couple points to the right of -4 to kind of figure out what this graph is doing. So I'm going to start by plugging in -5, -6, and -7 to the left. And to the right, I'll start with, again, 3 points, but if that's not enough to see what it's doing, I'll go ahead and add in some more. I went ahead and calculated these values in advance. When I plug in -5, I get 32 over -1, which is -32. These are all going to be pretty big numbers. So it's kind of a funky graph, but the process is still the same for how we're going to do this. So all these are super negative numbers, but if I were to graph them, we would see that they are going up a little bit as they go. And then -3, if I plug in -3, I get 12 over 1, which is 12. So that's at least on our graph. -2, when I plug in, I get 5 over 2, which is 2.5. -1, I get 0 over 3, which is 0. And I wanted to make sure I knew what I was doing, so I also plugged in 0 to get -3/4. Plugged in 1 to get -4/5. So it looks a little bit like this. All right, next one. Again, starting with the vertical asymptote, I ask myself, what can x not be? If I set the denominator equal to 0, I get x squared equals 4, and when I take the square root, it could be positive 2 or negative 2. So in this case, there are two vertical asymptotes, one at negative 2 and one at positive 2. For the horizontal asymptotes, I'm going to look at the degrees. The degree matches. Both are quadratic, so we look at the leading coefficients. My horizontal asymptote would be 3 over 1, which is 3. So I've got my asymptotes drawn in. Now I'm going to plug in some points. This time, when I make my XY chart, I actually have 3 sections I'm going to find. I'm going to find things that are to the left of negative 2. So maybe negative 3, negative 4, negative 5. I'm going to find numbers that are in between negative 2 and 2. So negative 1, 0, and 1. We need in between. Something's going to be happening. And I need to the right of 2. So maybe 3, 4, and 5. Oh no. Would be to the right of 2. So right, middle, left. When we plug in negative 3, we end up with 27 over 5, or 5.4. When I plug in negative 4, I end up with 48 over 12, or 4. And when I plug in negative 5, I get 75 over 21, which is approximately 3.6. I'll go ahead and graph those. So I'm going to finish up this branch by making it get closer and closer to my asymptotes. In the middle, if I plug in a negative 1, I get 3 over negative 3, which is negative 1. When I plug in 0, I get 0. And when I plug in 1, I get 3 over negative 3, which is negative 1 again. So in the middle, so got a stray little mark there, negative 1, 0, 0, and 1, negative 1. I have a little parabola sitting there in the middle. And then for my last section, this is actually an even function. So when I plug in these positive values, I'm going to get the same numbers that I got before. Oops, 3.6. And so my last branch looks right like that. These graphs can look so different, just graph to graph. So as long as you're getting your asymptotes in where they need to go, and you're plugging in your points correctly, you're making XY charts, your graph may not look perfect, and that's okay. You're just getting some points. You're showing me that you know how to get points in there, and that you know how to find and graph those asymptotes to go along with it.